Hi, welcome back to my channel Azure Learn. My name is Nagendra Kumar Singoti and today's topic is all about Azure Kubernetes Service. In short, it's called as AKS. Today's agenda would be creating a cluster and connecting to the cluster, run the application. It's a sample application, test that application and monitor the health and the logs for that application. I assume that you have a basic understanding of Kubernetes concepts. This is very much required. Like you may have to have the understanding of what are VMs, what are containers, what is containerization, what is Docker, what is Azure Container Registry, what is microservice oriented architecture versus monolithic application, these kind of things. Now let's try to understand what is Kubernetes. Kubernetes is an open source orchestration platform for deploying, managing and scaling containers. So if you are trying to orchestrate containers, that mechanism can be done using this Kubernetes. Now we will try to understand what is AKS then. What is Azure Kubernetes Service? Azure Kubernetes Service is a fully managed Kubernetes offering from Microsoft, and this is going to further simplify the container-based application deployment and event management. Kubernetes cluster looks something like this. It has got a master node and it has got the worker node. Here you can see in the picture the control plane, which is again the master node kind, and which would have the API server, the scheduler, controller manager and etcd. All these four components have their own individual responsibilities. And coming to the worker node also requires some components, and those components are the kubelets and then the container runtime, the kube proxy. These are all going to be made available in the worker nodes and in the master plane whenever you create Kubernetes cluster in Azure, that is Azure Kubernetes Service Cluster. So instead of you managing it on your own, Azure is going to give it to you in the ready-made fashion. Now we will try to understand what is the API server, what is its functionality. This component provides the interaction for management tools such as kubectl or the Kubernetes dashboard. etcd is the brain of the cluster, and this is to maintain the state of your Kubernetes cluster, and kube scheduler. Whenever you create or scale applications, the scheduler determines what nodes can run the workload and starts them accordingly. Kube Controller Manager. This oversees a number of smaller controllers that perform actions such as replicating pods and handling node operations. And in the worker node, if you see the kubelet, container runtime, kube proxy, these are all going to be there, and they also have their own responsibilities. Kubelet helps you to orchestrate requests from the control plane along with scheduling and running the requested containers. Kube proxy, this is going to help you to route the network traffic and managing the IP addressing and other services related to the pods. Container runtime, obviously, this is required to get you into the containerization approach, wherein the deployment of the applications in the form of containers in the worker nodes, the container runtime is required, and that's also going to be one of the mandatory components that's required in each of the nodes, the worker nodes. And let's try to understand what is pod. Pods, in fact, are the basic unit for running containers inside the Kubernetes. Pods usually would have one container. One pod would have one container. There could be some scenarios wherein pod can have more than one container. And this pod provides a way to set environment variables, attach to storage, and then have the information fed into the container, something like that. So the pods are responsible for running your containers. Okay? Right. Replica sets. Replica sets are considered a low level. That's the reason deployment is preferred. And what is that it's going to do is, this ensures that a set of identically configured pods are always running at the desired replica count. If a pod drops off for some reason, maybe unavailability of resources or something like that, a pod drops off, the replica set brings a new one online as a replacement. You see here, the replica count is set in the desired state as 4, and we have only 3 because one dropped, and then the new one is getting ready here. Coming to secrets. So environment variables, anytime if you have some confidential information like tokens, certificates, passwords, these kind of things can be attached to pods at runtime so that the sensitive configuration data can be stored securely in the cluster. Deployments. These deployments support rolling updates and rollbacks, and these rollbacks and rolling updates, all of these can be parsed and orchestrated in an efficient way with this deployment resource. Deployment is a higher order abstraction that controls deploying and maintaining a set of pods. Behind the scenes, as I said some time back, it uses replica set only to keep the pods running, but it offers a bit of sophisticated logic for deploying and updating, scaling a set of pods within the cluster. Daemon sets. Daemon sets have many uses. One frequent pattern is that daemon set to install or configure software on each of the host nodes. So let's say you have multiple nodes and you have one particular pod that needs to be running across all the nodes. Daemon sets provide a way to ensure that a copy of pod running on every node in the cluster. Ingress. This particular service, Ingress, provide a way to declare traffic ought to be channeled from the outside of the cluster into destination points within the cluster. This is a kind of load balancer you can imagine too. Okay, cron jobs are part of batch API for creating short-lived non-server tools, and they are excellent for running periodic tasks like backup, reports, and automated tests or something like that. Kubernetes resources such as pods and deployments are logically grouped into a namespace. So in case if you require the role-based access control, the best way is to have these namespaces utilized. There is a default namespace. When you are not defining which namespace you are trying to segregate the resource that you are trying to create, it goes and sets it directly into default namespace. And whenever you are trying to get the information like kubectl get pods you have asked for, and if it is trying to give you the information, it's going to give it from the default namespace. Kube system. This kube system is another namespace. Typically it is like you don't deploy anything onto this. This is a system-based resources are going to be into it. And kube public, usually this is also not used but can be used in some scenarios wherein if you would like to make the resources visible across the whole cluster and can be viewed by any user sometime, then you can make it kube public. So now let's get into the demo. I'm getting into the Azure portal, clicking on create a resource, and you can search for Azure Kubernetes Service in the text box here, or you can, if it is visible, click it here. I'm clicking on create a new resource group if required. AKS demo resource group I'm creating. Cluster preset configuration you can go ahead with, or if you would like to change, you can choose any one of these, whether cost optimized or batch processing or hardened access or dev tests. If you would like to have a complete look on this, click on this preset configurations. For now I am going with this standard configuration. Cluster name, I'm giving Nux AKS demo cluster. This is the name I am choosing, and let me select Central India. This is the one I always choose to go with. And more than 40 regions are having AKS clusters made available with. And availability zones, I'm going with the default. If you would like to reduce, you can choose those zones. And what is the Kubernetes version? As you know that the Kubernetes has evolved from various versions, and now the default is 1.2, 1.9, and there are later other versions also. Some are in preview also. I'll just go with the default one. And API server availability, if you are very specific on whether you require 99.95 or 99.5 to optimize the cost, depending on what is your requirement, you can select that. And the AKS cluster, minimum one worker node it would have, that is the primary node. That information, if you would like to change the size, click on and then change the size of the VM. For now I am going with whatever it is there in the default, and choose the option either manual or auto scale for the scaling method. I am choosing auto scale, and then leave these defaults in case of an auto scale required. Apart from the primary node pool information that we have given, if you would like to add additional node pools, maybe sometimes to run different kind of workloads or so, you can create it here. You can add the node pools here. And in case if you would like to enable the serverless Azure container instances mechanism, you can choose this option turned on. For now I am not going with that. And enable virtual machine skill sets is already checked, and I am going for the authentication. Authentication, two methods are available currently, the service principal method and system assigned managed identity method. And this would take a bit of time to get that ready. I'm going with system assigned managed identity. Both have the same kind of behavior. There is no impact on my AKS cluster whether I choose service principal or system managed identity. For now it's all same. Role-based access control, as we were discussing some time back on namespaces, if you would like to restrict certain users for certain access or restrict them from certain kind of actions, you can use this. So I am enabling this role-based access control. And encryption type, platform managed key, I'm going with its default. Networking, again for networking you have two different options, Kubernetes networking, Azure CNI networking. When you go with Kubernetes, this is the default VNet cluster with the default values. However, when you go with Azure CNI, this has got native integration with VNet features, which would allow you to have the customizable addresses given. All that would be advantages with Azure CNI. For now, I am going with Kubernetes. And load balancer, there is a standard load balancer that's provisioned already. Coming to the network policies, Azure network policy is not supported or compatible with Kubernetes networking. However, if you would like to put a network policy, you can choose the option Calico and then go ahead with it. On the integrations front, if you have Azure Container Registry or something that you would like to integrate it with, you can do that. Container monitoring is enabled, and then the log analytics workspace, I'm going ahead with the default one. Azure policy is currently disabled. Go to the advanced. In case if you would like to store any secrets and associate it with Azure Key Vault storage, you can do that. For now I'm not doing it. I'm not giving any tags also. I'm trying to get it reviewed, and once the validation runs successfully, I'm going to get it created. Okay, validation passed. Click on create. It has initialized the deployment and it submitted the deployment. Deployment is in progress. It would take 2 to 3 minutes to get the deployment done. Okay, so the deployment is complete and now we will try to go to the resource. Please observe here it is showing that the Kubernetes service, the encryption type, and then the node pools. One node pool is there, and the Kubernetes version, what we have chosen is this, and the node size is this. And we went by Kubernetes network, and then it is giving the pod CIDR, the service CIDR, the DNS service IP, and then the Docker bridge CIDR, all this information is from the Kubernetes network. For now, we have the container insights enabled and then the workspace log analytics is integrated. I'll just click on connect and it is showing me, helping me to understand I can go to the Cloud Shell here and then use these commands. So some guidance is given to me. Let me click on the Cloud Shell. This Azure Cloud Shell requires a storage. I'm creating a storage. It will take a minute or so. Requesting a Cloud Shell is succeeded and it's connecting to the terminal. Okay. So you have to set the subscription first. Select and set. And get credentials is the command with which you can get connected to the cluster that you are working with. I'm trying to get connected with this. Now it's saying that you are matched with this and this is the current context. Some sample commands if you would like to check all the deployments using the kubectl command. Kubectl is already installed in this. So these are the deployments that you can see that the kube system namespace. I'm using kubectl get nodes. This is one node that we have deployed and it's showing that. Let me try to create the manifest file and then deploy. I'm trying to create this file. This is a sample application given by Microsoft and I'm trying to save this. So this particular YAML manifest file is saved. Now if you observe, there is a deployment done for the backend which is using Redis cache, and there is a service also created for the backend, and there is a deployment done for the front end, the application part, which is a Python application, and there is a service created which is a load balancer. I would show you that. How do we check what are all these things that got created? So this is the front end which has got the load balancer and there is an external IP also aligned to this. Okay, so now I'll stop this CLI, the command shell, and I'll take you to the UI part and then show you. Come to Kubernetes resources and slowly this is getting enhanced with all the options. So you can check what are all the namespaces. Default namespace, kube public, kube system, and then what are all the workloads, the different workloads that are deployed. These are all the kube system workloads. If you see here the vote back and vote front, these are the two deployments that we just did, and services and ingress. This is where you can see that this Azure Front, this particular deployment, which is an application's front end, has got an external IP. You click on this, it will take you to this application what we have just now deployed. This is a voting application for pets. Okay, now we will try to understand a bit more about the replica sets. Okay, let me click on workloads, and here we have these deployments available and pods available, and we have the replica sets available. Here in the replica sets, if you see, the ones that we have deployed is only one replica set is available. And if you would like to see this in detail, you can click on this and you see that the replicas, one is current, one is desired. Where is that it was mentioned? It was in the YAML file that we have used to get this deployment done. So if you observe here, the replica set is 1. So what now we are going to do is, let me try to deploy an Nginx server. Let me give the YAML. I'm pasting, instead of me doing it in the Cloud Shell like before, now I'm trying to put it in the UI itself here, and then trying to add this, and it's creating the deployment. Okay, it's already created the deployment. You can see this. It is in fact in the yellow exclamatory mark stating that it's in the queue or it's pending to get deployed. Let me get inside. Okay, 3 desired as per the specification that we have mentioned in the YAML file, and 3 updated, 3 in total. All 3 are available. Okay, have a look. 1, 2, 3. 3 replica sets of Nginx server is available for me now. Okay, so this is the pods and then the replica information it's showing. I would take you to the YAML file also to show you the replicas. Okay, so now what I am going to do is, I'll try to show you a scenario wherein, let's say, one pod is deleted for some reason. Okay, I'm just trying to confirm the deletion. I'm explicitly deleting it here. Assume a scenario wherein, in a case it's getting deleted, what happens is, it's going to get it done. You see here, it's an yellow exclamatory mark. 2 of 3 is ready, and you can see that it's just now created this one. The reason behind that is the desired state and current state, it would keep continuously checking, and this should match. If there is a gap, it would try to do on its own, getting the other pod readily available. Okay, this is it from my side for today, and I hope the session was helpful. And if you have liked this video, please do give a big thumbs up, and don't forget to subscribe to the channel to stay tuned for upcoming videos. Thank you, good day, bye bye.